Hi everyone, my name is Evan Crotty. I am a third year PhD researcher in the University of Limerick in Ireland. I'm delighted to present my research on plantar-flexor electromechanical delay, the influence of contraction type and muscle tendon unit length on behalf of myself and my co-authors. The purpose of the study is examining a key component of explosive torque performance, electromechanical delay, which is a measure of neuromuscular performance. EMD is the delay period between muscle activation and force production and is muscle specific. And EMD time is primarily determined by the time taken to stretch the series elastic component to the point where muscle force can be detected. Now, two main factors we're going to look at in this study which influence this mechanism of explosive torque reduction. First thing that influences it is initial muscle tendon unit length. And in a study by Moreko et al. In 2004, they investigated involuntary EMD of the plantar flexors and found that EMD decreased as muscle tendon unit length increased up to the point where tendon slack was taken up. Second thing that influences EMD value is the contraction type. So as measured in that previous study, involuntary EMD is one method of measuring EMD, whereby the nerve is stimulated to activate the muscle. Second method is voluntary EMD, and this involves a large neural component. So at present, it's unclear whether muscle tendon unit length influences plantar flexor EMD of a voluntary contraction. So the aim of this study was to examine plantar flexor EMD across contraction types and different muscle tendon unit lengths. Moving on to the methods, our participants were 14 similar low to moderate levels of habitual physical activity participants. And participants were lying prone in a calibrated dynamometer for plantar flexor isometric tests with their ankles securely fastened using Velcro straps. Dynamometer and ankle joint axis of rotation were aligned with the knee joint fixed at 180 degrees in full extension. And surface EMG was recorded using a Delsis Trignal system from the lateral and medial gastroc and soleus. In terms of the protocol, first off, participants underwent a series of involuntary contractions at 3 different joint angles, 10 degrees plantar flexion, 0 degrees and 10 degrees dorsiflexion. And 3 contractions were performed at each angle with 12 seconds rest between the contractions and 2 minutes between angles. To elicit single pulse twitch contractions, the tibial nerve was stimulated. After the involuntary contractions, participants performed voluntary explosive contractions, again at the same 3 angles. However, 5 contractions were performed at each angle, and the 3 best were analysed. The 3 best were chosen as the 3 with no counter movement prior to the contraction, and the ones with the highest peak slope. And 30 seconds rest was given between contractions and 2 minutes between the joint angles. In terms of the processing, EMG and force onsets were detected manually, as this was seen to be the most sensitive, documented in a study by Till et al. In 2010, and also from pilot research we conducted ourselves. And EMD time was calculated as the difference between the first onset of EMG from the superficial plantar flexor muscles and torque onset. And the EMG was processed using a bandpass filter between 10 and 400 Hertz, using a 4th order Butterworth filter. Statistics, the effective contraction type and ankle joint angle on EMD was examined using a 2-way repeated measures ANOVA, and statistical significance was set at p less than 0.05. Moving on to the results. The results of the 2-way repeated measures ANOVA show that for EMD, there was a significant main effect for contraction type and for ankle angle. And the figure displays the trend of EMD values across contraction types and ankle angles. So just to focus in first on explosive EMD, which is the top half of the graph here. So as we can see, for explosive EMD, there's a decrease from plantar flexion to 0 degrees, significant decrease. However, there's no significant decrease between plantar flexion and dorsiflexion, or between 0 degrees and dorsiflexion. Potentially the lack of difference is due to between plantarflexion and dorsiflexion is due to the high levels of variability in the plantar flexion condition. Moving on to involuntary EMD, which is the bottom half of the graph here. There is a significant decrease in involuntary EMD from plantar flexion to 0 degrees. There was also a significant decrease in involuntary EMD from plantar flexion to dorsiflexion. However, there was no significant decrease in involuntary EMD from 0 degrees to dorsiflexion. So back to the aim of the study, where we're looking to quantify differences in plantar flexion EMD across muscle modes of contraction and different muscle tendon unit lengths. Main findings are across both contraction conditions, EMD tended to decrease while the muscle tendon unit length increased. For explosive EMD, the values were similar between muscle tendon unit lengths where tendon slack is considered to be taken up, neutral and dorsiflexion. For involuntary EMD, again, it was similar between muscle tendon unit lengths where tendon slack was considered to be taken up. The potential mechanism for the decrease from plantar flexion to the other two muscle tendon unit lengths is due to the potential presence of tendon slack at the plantar flexion angle. So to explain this further, when the length of the series elastic component is below a slack length in the muscle tendon unit complex, whereby the series elastic component can transmit muscle contraction forces to the bone, SEC needs to be stretched beyond the slack length to transmit muscle force. And the time taken to stretch the series elastic component is therefore prolonged in the plantar flexion condition if tendon slack is present, increasing the EMD value. So in the Mareko et al. 2004 study, they found no significant difference in involuntary EMD among the joint angles of 10 degrees plantar flexion, 0 degrees, and 5 degrees dorsiflexion, which are similar to the angles tested in this study. And they potentially explain this by tendon slack being removed at these angles. However, in the current study, although it's important to stress that tendon slack was not measured, the results suggest that tendon slack may still be present in the muscle tendon unit at a plantar flexion angle of 10 degrees, due to the differences we saw in EMD between the plantar flexion and neutral angle for both contraction types. So EMD has been shown from previous studies to be an important descriptor of explosive muscle contraction, evidenced by its relationship with maximal explosive contractile force and rate of force development. This study demonstrated that EMD tended to decrease as plantar flexor muscle length increased from plantar flexion toward dorsiflexion. And the study demonstrated that explosive neuromuscular performance may be enhanced as the muscle length of the plantar flexors increase. This has implications across sports where rapidly producing muscular force is a prerequisite for improved movement outcomes, such as during the sprint start or during gymnastic skills. An examination of how these delays may influence performance in such activities hence seem pertinent to inform both strength and conditioning and coaching practice. In terms of future research, we're looking to examine differences in plantar flexor function of sprinters and physically active individuals, again across a number of muscle tendon unit lengths, investigating delay periods such as EMD, looking at torque with torque measures such as maximum voluntary torque and rate of torque development, and looking at how the tendon influences plantar flexor function by examining tendon stiffness. Essentially, we're looking to build a neuromuscular profile of the plantar flexors of both population groups. Finally, I just want to thank the Irish Research Council for funding this research. I'd also like to thank my co-authors for their continued contributions. That's Dr. Laura Ann Furlong, Dr. Kevin Hayes, and Professor Drew Harrison. And finally, I would like to thank anyone for listening, and also I look forward to seeing everyone at ISBS next year, and I'm looking forward in particular to ISBS in 2022 to visit the home of the newly crowned Premier League champions, Liverpool. And if anyone wants to get in contact about the research and has any questions, I'm happy to be contacted by email or through Twitter. And thanks very much for listening.